All right, so there's been some questions on number 11 on the first review, and it says, recall the parametric equation used to describe the flight path of an object launched with an initial velocity v naught, feet per second, from the initial height, h naught, feet, at an angle of elevation theta degrees. These equations give the object's position t seconds after the launch. So here's your two equations we have. We have v naught, or x equals v naught cosine theta times t, and y equals v naught sine theta times t minus 16t squared plus h. From the problem, we notice that our initial velocity is 123 feet per second. Our theta is 35 degrees, and it says we're beginning from the ground, so our initial height is 0. Now, part A asks us to use parametric equations to model the flight path of a t-shirt launched by the cannon. So when we go to do that, for part A, we're going to say x equals v naught, so 123 cosine of theta, which is 35 degrees, times t, and y, and I should say like x of t. Hold on, let me find the eraser. X of t equals y of t equals 123 sine 35 degrees times time minus 16 t squared plus h, which is 0. Okay, so there's our part A, our parametric equations. Now let's go to part B. Part B asks, let me get to it, says, when the cannon launches the t-shirt, how much time passes before it lands? So we're talking about a cannon launching a t-shirt. So if you think about it, here's your cannon, it launches the t-shirt, it goes up, and it comes back down. Okay, so we're really looking at this equation, and we want to know, when does it hit the ground, or when is it 0? So I'm going to say 0 equals 123 sine 35 degrees times time minus 16 t squared plus 0. Okay, notice we could factor out a t, and it's going to give me 123 sine of 35 minus 16t. Okay, now I have two factors. Set each factor equal to 0. So one is going to be at time equals 0. Well, that's at the beginning. And the other one is going to be, where does 0 equal 123 sine of 35 minus 16t? So negative 123 sine of 35 equals negative 16t. So t equals negative 123 sine of 35 divided by negative 16. With your calculator, you want to make sure that you are in degrees, and I am. So I'm going to just plug that into my calculator. Negative 123 sine of 35, close my parenthesis, divided by negative 16. And I get 4.409 blah. I believe part B asks us to one decimal place. So we're going to say the answer to part B would be 4.4 seconds. Okay. And then part C says, how far away from the canyon does the shirt land? Okay, so how far away from the cannon does the shirt land? So we know it takes 4.4 seconds to get there, but I want to know what that distance is. Well, now that I know the time, I could put the time in. So C is going to be x of 4.4 equals 123 cosine of 35 degrees times 4.4. So I am going to do on my calculator 123 cosine 35 times, and I'm going to just do second answer to get a more precise amount. And I get 444.26. So what does it ask? Round to one decimal place. So I am going to say 444.3, and we are talking about feet. So our C is 444.3 feet away from the cannon. And D asks for the maximum height. Okay, well, when we talk about maximum height, that's this. Well, that's the vertex. So if I take this equation and I want to find the vertex, I'm going to say y of t equals, I can just rewrite it, negative 16t squared plus 123 sine 35t, and then it's plus 0. So remember, to find your vertex, you could take your negative b over 2a. Okay, so that's going to give me my x component, or in this case, it's going to give me my t, and then I'll have to plug it back in to solve for my the height. So plug it back in and solve for my y of t. So here I will take negative 123 sine of 35, negative b, all over 2 times negative 16. Plug that into my calculator. So I get 2.204, but I need to plug that in here to find the height. So negative 16 times second answer squared plus 123 sine 35 times t, so my answer. And we get 77.77. And this one asks us to round to one decimal as well. So It goes 77.8 feet up in the air. Okay. You also could have looked at all of that on your calculator. You could have plugged it into your calculator to the y equals, and then you could have figured out what this value was, because that's where it's going to be times 0. And you could have figured out what this value is, because that is where, or sorry, that's not times 0. That is where you hit the ground right here. And then you could have found the maximum here. So again, you could have used, like, if I wanted to find this vertex, I could have done second, calculate, and I'm calculating the maximum. So remember, this is where you choose something to the left, something to the right, and you guess. And again, look, we get 77.77. So same solution. So you could do it algebraically or you could do it graphically.